So, basically we were halfway through yesterday the float over. We will try to finish the other items in that, and then we will continue with the in-service design to complete the introduction, so that we can move on to design in the next, I think, coming weeks. So, how it is done? Basically you see here this animation, the barge is coming at a elevated by say 1 meter is a typical number, and then come when it is into the slot. Yesterday you have seen the video. So, basically there will be a minimum gap maintained. The gap is to make sure that accidental impact does not happen. During the matting process, several locations will have different wave heights, different sea states. So, if you have come very close with say half a meter or less than that, due to the movement of the barge up and down, you may actually impact. So, typical numbers is about 1 to 2 meters, depending on the sea state during which you are going to do this operation. So, if it is a very quiet weather, maybe you can come with a smaller gap, otherwise you have to do a larger. If you see this, so that impact process is very important. What you see here is very easy, but actually it is going to go up and down during the process of going down, and the process is not going to be so quick. It may take several hours, maybe 3 hours, 4 hours. During the process, water level may change due to tide. I think most of you might have heard this tidal changes, and then the sea state, because of the wave height on the barge may go up and down, and that may create elevation change. So, while you are ballasting water inside the barge, as well you are actually moving up and down. So, this may create additional forces, and also you will see that what is not shown in the animation is this lateral movement of the barge, which you can see on the sides of the barge. We have fitted with the rubber fenders in order to take the impact forces arising from the movement of the barge, which could damage the structure. So, once you have this and the gap between the barge and the structure is minimized, the movement can be reduced substantially. Normally we have about less than 100 mm gap, so that it does not roll. If the gap is too much, what will happen? It will actually start rolling, which may create even bigger problem. So, basically this design activity, before the structure is designed, you need to perform a naval arc analysis, which is basically a motion response with such a big topside on top, and then the sea state to be determined. So, what is the limiting sea state to which you can actually do this activity? So, you will do a reverse calculation instead of doing forward, because everything else is fixed, barge is fixed, your topside is fixed, location is fixed. So, what we want to find out, during which days we can go there and then start installing this platform. So, we will do just incremental, say half a meter wave height, everything is okay, 1 meter wave height, 2 meter wave height. Then you find out which provides you reasonable sea state that you can install. Of course, no wave height will be the best situation, but then you will go to the field and then wait for a very long time to find out there is no wave, means you may not be able to get it during say few 3 months. So, that is why you have to allow for higher wave height, but then you have to work out accordingly. So, that idea is called a float over matting analysis. This whole process is called a matting between the top sides and the jacket. The float over also actually used in many applications. In fact, last year we were doing one project in India. We were transporting a complete power plant from west coast to east coast. This power plant is mounted on a flat bottom barge. It is a 220 megawatt power plant. The complete facility is on a barge, so that it can be relocated anywhere wherever the power is required, wherever the source is available, like gas or fuel. So, I was consultant for GMR. They have had this in Mangalore. So, from Mangalore to Kakinada, we actually loaded that whole power plant on a ship and then brought back to east coast and loaded off. So, this activity is called float on float off. Basically you go, so you will see something like if you go to the first slide, you see here the ship is carrying a floating structure, which is basically a semi submersible. Semi submersible can float and perform its functions at one particular location for oil and gas exploration, but they cannot travel for a longer distance like a seagoing vessel. You must differentiate between a floating structure performing oil and gas production and a floating structure going for transportation like commercial vessels. They are two different classes, you require different design in fact. So, that is why most of the oil and gas applications we have floating structures like semi submersible. I think I have shown you various pictures of different types of floating structures. They are not supposed to be traveling long distance, not even short distance, because they are not classed for such design. So, they are not called seagoing vessels. You have to have a different classification and design. That is why any design that you make for oil and gas purpose for production floating platforms, they have to be transported by another ship. So, you see on the first down there, you are transporting a semi submersible, which is perfectly all right in floating condition, but when you try to maneuver from one place to other, they may not be able to survive the design conditions, or it may not be designed for such travel. So, that is why you have to load it on. So, how do we load this such a big structure onto a ship is basically in a dry dock. You can do this operation, or you can do it in a open sea condition. So, both of them will be floating, then you just submerge the mother vessel and bring this one on top and then deballast the mother vessel to take the load. So, very simple idea, both will be floating in one location and just submerge the semi submersible or the mother vessel and then bring it on and then deballast to take the load, go to the destination, exactly do the opposite operation. Basically, you will again submerge. As soon as the semi submersible comes into sufficient buoyancy, just pull it off. So, we call it float on, float off. And similarly, you see here a jack-up rig is being transported, because jack-up rig, if you actually tow by tugboats, they may take several weeks to reach another destination. So, if you want to take it very quick, I want to do the drilling in say next week, I transport the jack-up rig on a ship, which is again expediting the process. You see here on this, so many small boats are being transported by a bigger ship, again float on, float off, because the mother vessel will submerge. Otherwise, what will happen, you will end up lifting this and putting into, which actually may not be possible, because either it will be too big a structure, too heavy, cannot lift, or when you do lifting, these ships or the boats may not be able to take the stresses, because they were not designed for, and that is basically the idea. You see here another ship is being transported on another bigger ship. So, this kind of ideas is using float on, float off in water most of the time. Conventionally, for oil and gas applications, we have two types of matting operation. You can actually do a float over or float around. For example, if you have a central column, I think I have shown you a gravity platform. You know what is gravity platform? No? You have a central concrete column, where you cannot do this float over operation, because big column, 20-meter diameter column is there. So, you can have two barges coming on either side carrying the top sides. So, you can float around. So, this is also sometimes used, but not very common. Then, so the video what you have seen yesterday gives you a clear idea how it is coming in and basically pulled into the legs. So, what you see here in the picture here, these 1, 2, 3, 4 are the legs of the jacket, which is already pre-installed, and there are 4 additional legs hanging on the top sides, and additional 4 legs which is in a little light color supporting the deck on the barge. So, you will have 8 legs on the deck, whereas 4 legs on the jacket, because 4 legs for supporting during transportation, which is in the inside, and 4 legs will be hanging in line with the outer legs. So, when you go inside there, just set down. One of the biggest problem is swell conditions. I think when you study your hydrodynamics course, you will be introduced with long period waves, which are potential threat to any installation. Basically, the response of floating systems will be abnormally high, especially for this kind of ship shaped vessels. If you have long period waves, even the wave height is smaller, you will see that the response will be larger, sometime may go into resonance, especially the ships. If you see the natural period could be around 10, maybe 12 seconds, and if you have wave periods also 10 to 12 or 14, you will see that the heave response could be substantially higher. In fact, we had a similar problem when we were trying to load out last year in West Coast. We had a very big problem because West Coast is subjected to long period swells coming from Indian Ocean, especially the distance of travel is very large from Africa. You could see that we could not really do it. Then we have to do it in a sheltered water in one of the port, because we supposed to do it in open sea condition, which could not be performed because of the swells. 2 times we failed. Then we brought the whole thing into Mangalore port, where the swells does not enter, and then could do the loading. Whereas in the East Coast we do not have such a problem. We could easily load out, unload it in an open sea condition very quickly. So, the swells, so wherever this sea conditions are expected to be long period swells, you should avoid it, number 1. If you cannot avoid, then we need to design it in a slightly different way with a sufficient margin. And normally wave heights shall be less than 1.5 meter. So, you can imagine if you go to a beach even today, you will see easily this type of wave height 1 meter, 1.5 meter. So, you can imagine the period of this installation, you will have a long wait offshore. Unlike the other installation, maybe you can have a slightly higher sea state, whereas this float over condition, though it is very economical what we were talking about, but then the period available for you to get this operation could be very limited. In a year you will get maybe 20 days, 30 days maximum, in 2 months, 3 months, and remaining period you can't do this. So, if you miss out this, for example, then you will have to wait for the next year to come. So, the whole business becomes little critical, and that is why you have to be careful when you are performing this idea. So, typical weather window means what is the period during which we need to start this operation. The whole float over operation can take only 6 hours, but the preparatory activities and the post activities after float over could take totally about 2 days. You should wait for right weather condition, remove the sea fastening and go inside, get your alignment done. So many activities will be performed during this installation. So, basic idea is that is the arriving condition, and then you will be seeing around typical about 1.5 meter, and I think we have seen this video, you will be able to appreciate this. So, how do we enter is the biggest problem when the vessel is such large size. You see here on the left side and right side there are 2 boards aligning the vessel such that it can actually go in the slot. Otherwise, what will happen, even a small deviation can damage the structure without any warning, because the mass of the vessel is so high that even a smaller or the low velocity movement can damage the jackets very easily. So, that is why you see the alignment, and also you will have the wires connected to the forward ship or the boat going there. Sometimes what we have is, instead of these wires going by boat, we will have a winch connected to the jacket legs, and then the winch will actually move the ship slowly in a controlled manner, or you can have a winch on the ship, but the wire is connected to jacket. Either way, you can just bring it. I do not know whether we have, you can see here the black color wire actually is attached to the jacket, so that you will have actually crisscross wires. One wire is going from here to here and another wire is going from here to this leg. So, when this is being pulled, the control is there, while these wires are connected to actually the winch. So, the winch will actually slowly rewind, so that the movement of the mother vessel is slow and steady, and also inside the slot directly, something like this. If you see here is the winch taking the wire opposite direction. So, when the whole thing is moving in, it is fully controlled. So, that is the critical position. So, that is the time what happens is the legs are aligned. So, you do a laser control alignment first, make sure the leg on the deck and leg on the jacket are aligned perfectly, and then you start deballasting the barge. Now, there is an alternative method. Basically, whenever the situation is not right, for example, you start ballasting, the rate of ballast and the rate of increase of water level due to your tidal changes. If the tidal changes are faster, then your ballast, what will happen? You won't be able to touch, you won't be able to touch down at all. So, is it a good idea to do this operation in a rising tide or the lowering tide? You have to plan it, but lowering tide is also a big danger, because if it goes faster than your expectation. So, what we need to do is actually at a particular site where you are going to do this installation, look at the rate of change of tidal elevations and make sure that you fix up a right time, not at the lowest time. You have to start just at the peak of the tide and then start doing this operation. It will help you because your ballast requirement will come down. You can manipulate that, but the available time will be maybe 2 hours, 3 hours. By the time you might see that the tidal cycle is about 8 hours. So, you will have that only a limited time during that particular period. So, you will have to fix up, do this operation and get away, because if you do not get away, what will happen? The rising tide will take the barge up and then hit it back. You understand the idea, no? Because even though you have installed, if the barge remains there only, the barge will just go up and then hit against the structure. So, you will have to just remove this as quick as possible. So, if this whole thing is not going to be nice and clear, because you are doing in open sea conditions, things can change. You have a predicted tidal chart and measurements, you have a weather conditions forecast, but you go there, in case if you get into problem, what remedies we can have. The important thing is you pull it back, isn't it? Just reverse it and go away from the location and wait for good weather conditions. But for some reason, if you are unable to go away, what will happen? You will lose the jacket, you will lose the deck by damaging. So, in order to avoid, what we normally have is, I think that slide is not here, but what you can see here, instead of supporting all of them only by simple welded supports, you can support the whole structure by hydraulic jacks. So, if you have say 10 or 18 numbers of hydraulic jacks below the structure, in case if it is moving down too fast, the hydraulic jacks can lift the structure by half a meter, whatever required to stabilize, or if the movement of the deck is too slow compared to what you expected, because of ballasting is going very slow or you are unable to do ballasting, then you can bring the jacks down. So, this we call it active float over. Instead of you purely rely on only ballasting or deballasting, you can use the jacks to move up and down the whole structure. But one of the problem is the hydraulic jack capacity could be very large, for example 10,000 ton. So, you need to have say 4 or 8 jacks, each one of them 2,000 ton capacity, each of the jack could be something like 1 meter diameter. So, expensive, but very safe. So, this two methods of float over, one is passive float over, wherein we actually flood water and try to do the movement of the barge, or you can actually keep the barge in the same elevation, just movement of the cargo by means of hydraulic jacks, which is called active float over. Or many times we do the combined, we have the hydraulic jacks, we have the provision for ballasting, you go to the field, you decide according to the situation, either I will ballast or I will do the hydraulic activation, so that I am feeling 100% safe that successful installation will happen. So, most of the projects you have both of them installed. So, you see here the critical time is the alignment of the legs. So, how do we do survey? Basically nowadays most of the devices available in laser control. So, if it up on the jacket legs as well as on the deck structure. So, align it to millimeter accuracy, in fact very accurate nowadays both in terms of horizontal plane and the vertical plane, so that it does not create problem. But imagine whatever we do this, we still will see that the load transfer could be slightly dynamic, it will not be like taking the weight and then just nicely placing it. So, you will see that there will be a impact force, because sudden and you also see it is not one support, you got series of support on left side, series of support on right side. As I mentioned, you may have actually 4 or 8. You see here in this particular one 4 on left side, 4 on right side, whereas some cases you will see 2 on left side, 2 on right side, depending on the design. if you want to distribute more loads, but most of the time we will have 4 only, 2 on the left, 2 on right. This particular project they had 4. So, you see here when it is just impacting like this, what will happen to the steel at this top? It may actually get damaged or locally yielded, there may be dent. So, in order to prevent this, we need to have some active devices built in either in the lower part or in the upper part. So, imagine if you put a hydraulic jack inside, what will happen? During the impact, you can activate the hydraulic jack either to extend or to, but the timing of activation is so difficult to determine, isn't it? We do not know, because 8 supports, one of them may touch because of slight tilting of the bars, one of them may touch first, the other one may not. So, this will be very difficult to manipulate. So, what we normally do is we place some kind of elastomeric devices inside the jacket leg, so that even if the impact happens, the elastomeric devices will compress, take the energy of impact by internal work done, transfer the reduced forces to the structure. So, that is the idea behind. So, you see this next picture, we normally implant inside the jacket leg. This is a jacket leg, what you see in here, this is the jacket leg. So, inside here you place series of elastomeric pads, is very similar to rubber, but very hard rubber, and you have a steel plate at the bottom to prevent this one from going down, because it is hollow, no, jacket leg is hollow, and then you have filled with sand. So, basically the bottom is welded plates, you have a sand, this plate is not welded to the inside, it is actually floating on top of the sand, it is just resting on the sand. On top of this plate you place several of the elastomeric pads, on top of it you have a receptor cone, just like a metal piece prepared in such a shape that it will receive without bigger problem, So, basically when it is impacting there, the elastomeric pads will compress and the shock absorption will be taken by the sand in here. You are not seeing that dot color, but basically inside here is a fully filled with sand. You might see, sand is a very good absorber of shock. Gravel, in fact, many times we use gravel, no. If you see the railway tracks, why we fill with gravel is the good absorption of shock energy, and basically one of the biggest problem is you need to decide what will be the compression required. Now, we have about 8 pads placed here. So, under the loading, if it compresses too much, what happens? The load will be transferred to this, because you need this whole piece has to go inside under the compression, isn't it? Otherwise, you will not be able to get the contact of the deck leg and the jacket leg for welding purpose, because you are going to do the welding. If it is compresses too much, then it is a problem, the impact load will come. If it does not compress, then you will not be able to do the welding. You see the problem. So, the design of this elastomeric pads needs to be such that the compression is exactly what we wanted. If it is a 1000 ton reaction, you need to design in such a way that under 1000 ton it will be able to compress at least this much, so that you will be able to do the welding. So, otherwise you will not be able to make a connection between the deck. All of you are able to see this, no, because this piece has to go inside, so that the deck can come and do the welding. So, basically that design has to be proper. So, this assembly is called a leg matting unit, is nothing but a shock absorbing device placed inside. Sometimes what we do is exactly we reverse it, we place this one inside the deck leg. So, sometimes we call it deck matting units, here we call it leg matting units, does not matter, it is basically a device to absorb the shock during the matting process, and this is an elastomeric device to reduce the impact. At the same time, you should have sufficient deformation such that the outer and outer comes in contact. So, circumferential welding can be done all around, and the load transfer can happen. So, in doing this process, actually if you look at it, it is first touch down, maybe 0 load, but already touch down, and then slowly gradually the load will increase. It will not be a sudden process, because you are doing ballasting gradually. So, at this position that the receptor cone should have already compressed to whatever the design amount what we require. So, that is why you are seeing a single contact line between the gray color and the yellow color. So, somebody will go around and do a welding. Once you start welding, you can see here several fellows have gone there and disconnected the supports, and immediately, unless you disconnect the supports, this barge cannot come out, is not it. So, you go and disconnect the supports, quickly pull the barge, the way it came in you have to reversely pull out. What will happen otherwise? If you see this barge, if you pull out in the same direction, the structure that you have installed will get damaged, because there will be bridge, there will be mast on the ship. So, basically you will have to go in the reverse direction, the way that you come in and just go outwards. So, you will be seeing something like this underneath. These were the supports that were actually supported during transportation to the site, and just pull it backwards, and once you come out, then it is very safe. So, this undocking also is quite important, because the timing, if you just manage to pull out in time, it will be good, otherwise. I think that gives you an idea about various installation. I think we can summarize first before going on to the. So, what we have discussed is fabrication in the yard, and then load out. You have seen a video, I think most of you might have understood what is going on, and then load out can be done in two ways, either by skidding or by trailers, or by the third way by lifting, is not it. So, you should be able to make some simple sketches. You have seen so many nice pictures. For examination point of view, describe the load out by trailer, you should be able to make a simple sketches and write description of what I explained. You won't be able to find in the textbooks, you understand the idea, no? So, you should attend the classes, so you can write. And basically transportation, what exactly is going on? Transportation is the jacket and deck being relocated from the yard to the final site by barges or by ships, and we have discussed about various methods of transportation. And then once you reach the final place, the jacket can be installed by lifting or by launching, and there again lot of sketches you have seen, drawings, pictures. You should be able to make a simple clear hand sketch, but not scribbling, you should write clearly, and the procedure how we described. So, if you are asked to describe a typical jacket installation from yard to site, you should be able to make a simple step by step sketches, describe the stages involved, nicely explained. So, launch by means of pushing the jacket into water, or lift by cranes, but ultimately both have to freely float on water, and you have to append it using crane. So, you have two methods of appending, one the appending by crane or self appending by the jacket itself, which will come to vertical position by means of its own inherent buoyancy and center of gravity correctly manipulated, or else you do manual manipulation by flooding water and make the upright. So, I think this whole process from yard to final installation is to be understood, because each stage we have different types of loading to the structure, and that needs to be taken into account when we are going further for the design activities. So, what are the loads that is arising from this activity alone, because after installation is a final service condition which we know the loading, whereas during this process, during load out, what is the load? Load is only self weight, nothing else, is not it, but the design condition is different. When the jacket is in service, the jacket is in vertical condition, is not it, whereas in fabrication and load out, jacket is in horizontal condition. So, you can imagine, if you have studied mechanics, a column become a beam, behavior is different. Column carries axial load, beam carries bending loads. So, you can see you will have to design the structure which was designed for some other boundary condition. All of you familiar with boundary condition, no? support conditions. So, you see here the jacket will be subjected to severe bending. So, basically analysis, what you are going to do is change the boundary conditions, change the loading direction and carry out the design. But in addition, you have seen the video, during the load out process, basically the structure moves up and down because the barge is, I think if you watch the video, you can see that at the time of transfer the barge is heaving up and down. So, you can see that there could be a push upwards or push downwards depending on the location of COG, and that can cause additional bending loads due to support settlement. I think you might have studied in your applied mechanics, bending moment due to support settlement. So, that could actually cause substantial loading. So, this load out is all about its own dead weight, no external loading is going to come except maybe some small wind load, but predominantly dead loads, but manipulation by different boundary conditions. So, load due to installation, first stage load out, load is purely dead load. Second stage, you put a jacket onto the cargo barge, towed to the open sea condition. So, the barge is going to roll and pitch and move up and down because of external sea condition. So, what happens to the structure? The structure will be subjected to forces from motion. If you have travelled by boat, you could easily visualize. If you go on to the top of the deck, what will happen? You will feel giddy because of the motion forces applied onto your body. Basically, the inertia forces will come. The heavier the structure, more forces will be generated. So, these motion forces have to be accounted, but basically the loading is arising from its own self weight, no other external forces. The force is due to its own weight, but because of the roll and pitch motion, you will see that the inertia forces are produced. So, you have to design the structure for that type of forces. Then when you go to the site during launching, similar to load out, you may have a different support condition. When it goes into water, you will see partly submerged, partly on barge, and then make it upright. So, each stage of installation, its own weight is a problem. By this time you should realize that that means reducing the weight of the structure is the most important aspect of the design. The lesser the weight, less problem for us. After all, it also means money. More the weight that you want to put, more money you are going to spend, more trouble you want to invite, because increased loading can cause increased stresses. So, that is idea behind offshore structures, always minimize the weight. And also when you go to in final service condition, when the jacket is upright, more number of members means more amount of wave loading, isn't it. So, the minimum number of members and structures required, you should design it so that you do not invite additional loading. And then once you place the jacket on seabed, we will be able to do the pile driving onto the template. I think all of you are familiar with now the what is called a template. The whole jacket is called a template because the purpose of making this frame is to do the piling through the legs or through the skirts. That is the idea, so that you can drive the pile and do the connection between the pile and the jacket. Once it becomes integral structure, then you can place the top sides, and top sides we have only two method of installation. One is by lifting and putting on top of the jacket which is already installed, or by float over, whichever by means. So, if it is a lifted object, lifted design, you may have a single lift, sometimes even 5,000, 10,000 tons. If you have a bigger crane, you can actually place the whole thing in single piece or split into several sub pieces, assemble them on the jacket, or you can do a single float over installation. So, I think this whole business for last 3 classes we were discussing, the idea is why we need to know this. If you do not know this, the design cannot be performed. Unlike the onshore structures, you do not need to know actually all this. This will be normally by the construction team will manage that the size of the structure that you have designed will be safe even during installation. They will just make sure that they do not come and change, because the installation related design is not going to govern or increase the stresses for on-source structures. For example, when you make a multi-story steel structure, they are not going to make the whole structure built somewhere and move it. You normally have a prefabricated pieces, small pieces, bring it to the site and assemble it at the site, isn't it? Whereas in our case, the design is going to be governed by what methodology that we are going to adopt for the installation. Either it is a trailer or it is a skidded, or by load out by other methods, or float over. Every decision that you are going to make on installation, it is going to change the stresses, it is going to change the member sizes, and that is why you need to know all this, so that you can do the activity accordingly. Once it is installed at the final location, then it comes the final service design. That means during the next 20 years or next 30 years, the platform is going to be at that location. So, we need to see what are the loads applied onto the structure. I think we have seen on the first day, so gravity loads, environmental loads, and then facility loads, and then live loads. So, all of them is going to be present at that time. We have to design as similar to any other structural design, except the predominant loading is from wave and current, which we are yet to see. Probably sometime next week we can do that. I do not know how much hydrodynamic wave theory you have been taught in the classes. Not yet. Otherwise, I will give a quick introduction and then we will go ahead, because it is getting too late. So, basically the in-service design is all about designing the structure at the location where it is performing its hydrocarbon exploration, and 99% of the cases hydrodynamic loading will govern the design. Gravity loading will be very small compared to the hydrodynamic loading in terms of its severity, not the magnitude. Magnitude could be smaller. For example, 10,000 ton topsides, maybe 1,000 ton horizontal wave load, but that 1,000 ton can cause a huge trouble because it is a bending load compared to the 10,000 ton gravity load, which is going to go as a axial load to the structure. I think all of you, if you have studied your mechanics, you take a cantilever column, axial load could be potentially a higher number, whereas the bending, the horizontal load with a smaller amount, it can actually deform and fail by bending. So, that is where, even though magnitude could be smaller, but the governing case will be the environmental loading. So, the structure needs to have sufficient strength in doing so. So, we will just see that. So, what is all about in-service design? We will just look at 1 or 2 slides, then we will carry on in the next class. Hopefully, I think at least the week after next week we can go to hydrodynamic loading. So, it is basically simulating the structural system, whatever necessary for producing oil and gas, basically to make sure that the structure performs within the limits of code allowables in terms of stresses, in terms of deformation. So, normally you need to do a 3-dimensional frame analysis. If you have studied structural analysis in your previous courses, or in fact we have a structural analysis course in this MTech, I think. I do not know whether all of you have, but at least the OE3 or OE4 people will have a special course wherein we teach about various forms of structural analysis for both floating structures and fixed structures, and then that will give you an idea of the member loads or loads arising from various cases of loading, and then each of these members needs to be designed against a particular design code, which we will see in this course. Several codes are available, as you might see Indian codes or other national codes, US, UK, European codes, ISO codes. So, we will have to select a suitable code for the design and basically perform the design of structural element, one single piece in the complete system, but the system needs to be analyzed, means frame analysis have to be carried out. There are several manual methods you might have studied in your applied mechanics course. You might remember moment distribution method. You have heard of this name, simple frame, portal frame, you can perform bending moment calculations, shear force calculations. What other methods are there? Moment area method, you have heard of this, slope deflection method. All of them will be leading to one particular solution for bending moment shear forces on a frame. Now, if you have a simple portal frame, maybe okay, you can spend half an hour, 1 hour, but if you see this structure, I think I will show you one bigger picture. Where is that? There is no picture in here. We saw that one picture the other day, no? Maybe you take a picture like this. Big structure, thousands of elements. Imagine if you have to perform by manual moment distribution method, it may take several days. Of course, it can be done, but it may take several months. That is why nowadays the same method what we are talking about, moment distribution method or other methods, a simplified matrix form, we call it matrix method. You know, it's all principles are similar, ultimately solved by computer, by making a generalized solution for a larger structure. So, as early as 1960s, people have come up with simple computer solutions based on matrix formulation of these bending moments and shear forces, and nowadays several softwares are available, many softwares. Every software can do the simulation of a 3-dimensional structure like this, and then apply the loads, perform the boundary conditions. They can give you the load on each of the member, shear forces, bending moments, torsional loads, all can be obtained from 3-dimensional analysis. As long as you simulate the structure in accordance with what is required, apply the loads, support boundary conditions provided correctly, then you can get the loads, which nowadays nobody is doing hand calculations. That is one of the part, one of the saddest part, because even for simple structure you start using computer, because computer is available, but you have to verify that the what you have applied, what you have simulated is going to reflect the real condition. If not, you may be simulating something, but in reality something else. So, basic idea is what we are going to see here is to simulate the behavior of the structure in the service condition, and basic idea is supply loads and boundary conditions, and this is called in service, in place, because what we have seen before reaching the site is called a pre-service, and in service is nothing but the operational conditions. What we have to look at so many things, the geometry of the structure. I think by this time you could easily understand how the geometry was arrived. You could recollect how the geometry of the structure, whether it is 8 leg, 6 leg, single leg or 4 leg, is basically based on the top side area requirement. If it is larger the area, you will place 4 legs, 8 legs, or if it is a small top side, then you put only 1 leg, is not it, mono tower. So, the geometry has to be decided by the engineer who is arriving at the configuration, is not it, and adapt whatever, whether it is a main leg pile or skirt pile also have to be decided depending on the site. If it is a 100-meter water depth, maybe main leg pile is no good. I think I have already explained why, because the pile is going to be inside, unnecessarily increasing the weight. So, you can have a skirt pile on the side, so that you can reduce the weight. Member sizes, wave directions, hydrodynamics, coefficients you will see later on. Loads and load combinations, what are the loads can actually coexist at any time during the operation. So, we will go through one by one. I think we may require maybe 2 classes to complete this. Only what we will do is we will just skip the hydrodynamic coefficients, because we will do that during the load calculations using wave and current. So, ultimately we do soil structure interaction, because this is a cantilever type of structure. So, we need to do a pile soil interaction, and then dynamic effects, because the loading is wave load is dynamic, and then we design the piles, design the members. So, in this course almost most of this will be covered except the pile soil interaction, which we will be taking in the next semester, I think one of the course. So, we will not go too much detail into that, because there is a full fledged course wherein structure, soil, pile interaction will be designed. Dynamic effects I will just touch upon, because you have a separate course, dynamics of offshore structures, in the second semester or first semester? Second semester. So, supposed to be in first semester anyway. So, that I think we will just introduce little bit, so that you will appreciate what is the importance of dynamics for the picture structures. I think we will stop here.